Hello everyone. So today we're going to talk about continuity and discontinuity. So first you're thinking, what even is continuity? So I'm going to give you an informal definition first, and then we'll talk about a more formal definition. But informally, we say a function is continuous if we can draw its graph without picking our pen off the paper. Alright, so hopefully after me giving you a drawing of a function, for example, that is continuous, you kind of see what I mean by saying a function is continuous if we can draw its graph without lifting your pencil from the paper. So I'm literally, to give you an example, going to just draw something pretty random, okay? But for example there, what I just drew in purple would be an example of a continuous function, because I did not have to pick up my pen off paper to draw that. Okay, so what is discontinuity then? So informally, we say a function is not continuous. Okay, so not continuous at x equals a, so at a specific value, if we have to lift our pen from the paper to draw the graph of f at x equals a. Okay, so before I get into some graphical examples, there's actually 3 different types of discontinuity. So the first type is removable discontinuity. Okay, and the reason why it gets its name removable discontinuity is because literally right at that value x equals a, it looks like a point was just removed from the graph. Like everything looks nice and smooth up until that one point where there's like a hole in the graph, and then it continues onward except for that one hole there. So if I literally just put in that one point where that hole is, then the function would be continuous. And so that's why we say it's removable discontinuity, because it physically looks like a point was just removed from the graph at that point there. Okay, and the second one is what we call infinite discontinuity. And I'm just going to put in parentheses that College Board refers to this as discontinuity due to a vertical asymptote. Okay, so a lot of times you're going to hear that they say, oh, this is discontinuity due to a vertical asymptote. And so more informally, we call this infinite discontinuity. And that's basically because at that point where it's discontinuous, you see one side's going towards positive or negative infinity, and then the other side is doing the exact same thing. It's going towards positive or negative infinity. And so hence also why College Board says that it's discontinuity due to a vertical asymptote, because there's a vertical asymptote right at that point, x equals a, and so that's what's happening there. Okay, and then the other part, the last one, is what we call jump discontinuity. And when you see this as far as an example, you can see that it physically looks like you jumped. Like there's this big gap in between the two pieces of the graph, and so you can see what I mean by that. So in other words, what I'm trying to say is when we look at these graphs, you kind of see intuitively like where they get their names. So in this first example here, looking at this graph, you can see that at x equals a, there's what we call removable discontinuity, right? Because again, like I was describing earlier, you can see that it looks like at x equals a, there was just one point removed from the graph. And if I were to put that point back in, then the function would definitely be continuous. Moving on to the second graph, we can see that this is infinite discontinuity at x equals a. Okay, because we can see here, like I said, that there's a vertical asymptote at a. And of course, if I were to draw this graph, right, if I were to draw this graph at x equals a, I would definitely have to pick up my pen off the paper to then draw the bottom parts of it here. Okay, so we can see that. So where I picked my pen off the paper is where it's discontinuous. And now, because you see that there was an asymptote there, that's where we're getting the name infinite discontinuity. Looking at the third one, if I were to draw this graph, of course, at x equals a, I'm going to have to pick up my pen off the paper. But here, like I was describing earlier, you can see, right, that there was a jump or a gap in between those two pieces of the function. And so that's why we call this jump discontinuity.